Hello, and welcome to today's ACM Tech Talk. This webcast is part of ACM's commitment to lifelong learning and professional development. ACM serves a global membership of nearly 100,000 computing professionals and students. My name is Terry Coda. I'm the CTO for a company called Marine Learning Systems in Vancouver, BC. We're an e-learning software and services provider to the maritime and resource industry. My background is in distributed systems architecture and software development. I've been an ACM member for a very long time, I think since 1986, and I've been actively volunteering for the ACM since 2001 in a variety of roles. For those of you who may be unfamiliar with the ACM or what it has to offer, here's a little background information for you. The ACM offers educational and professional development resources that bolster skills and enhance career opportunities. Our members can stay competitive in the constantly changing world of computing with a range of ACM Learning Center resources, which you can find at learning.acm.org. You can see some of the highlights on your screen. ACM recognizes the role of computing in driving innovations that sustain competitiveness in a global environment. Among the things that ACM provides are timely computing information published by ACM, including the communications of the ACM and Q magazine. Access to the ACM Digital Library, the world's most comprehensive database of computing literature. International conferences that draw leading experts on a broad spectrum of computing topics. Support for education and research, including curriculum development, teacher training, and the ACM Turing and ACM Prize in Computing Awards. And finally, the updated ACM Code of Ethics, which is a collection of principles and guidelines designed to help computing professionals make ethically responsible decisions in professional practice. The ACM enables its members to solve critical problems using new technology that enriches our lives and advances our society in the digital age. Before we get started, I'd like to quickly mention a few housekeeping items shown on the slide in front of you. First, the slides will advance automatically throughout the event. On the bottom panel, you will find some additional widgets and resources. If you are experiencing problems with the slides or the audio, the easiest solution is probably to refresh your browser, for example, by pressing the F5 key in Windows or Command R if you're on a Mac. If that doesn't work, try closing the window and relaunching the presentation. To control volume, adjust the master volume on your computer in the way that you probably would normally. If you have questions during this talk, please type them into the Q&A box at any time and click the Submit button. I'll be organizing these questions in the background as Luke speaks, and we've got some time reserved at the end of the talk to answer some of those questions. This session is being recorded and will be archived. You will receive an automatic email notification when it becomes available. You can check back at learning.acm.org for updates on this and other upcoming webcasts. At the end of the presentation, you'll see a survey open on your screen. Please take a minute to fill it out because it helps us improve our tech talks. You may also open the link to the survey at any time from the resources window. You can use the Facebook and Twitter widgets at the bottom panel to share the presentation link with your friends, as well as tweet comments and questions using the hashtag #ACMLearning. We'll be watching for your tweets. We also have a community discourse page to continue the discussion after this webcast, including questions that we won't be able to get to live during the Q&A session. Today's presentation is Integrating AWS Lambda with Your Majestic Monolith by Luke Close. I met Luke a few years ago as part of a CTO group here in Vancouver, BC. Luke is one of those people who always have something interesting to say, and when I heard him talking about doing some work with AWS Lambda, I knew that it would be interesting to hear about his experiences. But first, a little background. Luke is a software developer turned entrepreneur who has been building software for more than 20 years. Luke's career started in 2G and 3G wireless networks, and he has since been involved in building products in enterprise security appliances, enterprise collaboration software, and other startups. In 2012, Luke turned a civic hackathon project into a real product and company that became ReCollect Systems. ReCollect is a communications platform for cities to communicate with residents about public works issues such as solid waste and recycling, and it's used by hundreds of municipalities across the US, Canada, and the UK. Luke is also an ACM member. So Luke, without further ado, take it away.
Awesome. All right, I'm just sharing my screen here. So we should see this come up in a second. And then Terry, I'm assuming you can hear me?
Yes, I can hear you.
Awesome. All right, well, let's go then. Okay, so welcome to my talk. It's called AWS Lambda and Your Majestic Monolith, aka serverless for those of us without servers. Let's get started. So in this talk, what I'm hoping to do, this is not like a super deep tech talk. We're not going to like just be going over lines of code, but I'm really going to help you understand what is Lambda, AWS Lambda, why you should care about it. I'm going to talk through a couple examples of how it's helped us at ReCollect, and then talk through some of the challenges and lessons that I think you should be thinking about as you're approaching this technology. If we have enough time, if I whip through these slides, I might do like a mini bonus section to do some mapping, some wordly mapping, and talk about the context this technology exists in. So a little bit about me, kind of, this is already mentioned by Terry, but yeah, developer of 20 years, kind of like worked through a bunch of different products. And about 8 years ago, we started ReCollect. And so we're a platform that, that is a communications platform for cities around solid waste and recycling. A little bit about our infrastructure to give you a context of where I'm coming from as a CTO and architect of our platform. We at ReCollect like boring technologies. So we don't find ourselves using, the absolutely newest technology on everything. But we try to pick and choose. So we like kind of really boring, stable technologies like Postgres. And we have a pretty kind of standard, I think, stack, right? So EC2 servers, REST APIs, kind of back-end job queues, JavaScript or mobile applications that call into the REST API, and a majestic monolith. Like I think this word monolith has kind of gotten, people don't like it lately, and microservices are all the rage, but the monolith is a pretty good way to go unless you have a giant team. Anyways, that's our situation. And then we have a handful of smaller little services that support our core app. So like, what is Lambda or serverless? I think there's kind of two lenses on this. I think it's not a big deal, but it's kind of a big deal. And so I want to kind of present these two coins. I think this is a good framing. And then I just want to make a little note here about serverless. So serverless is both a general term describing an architecture. Like a serverless architecture is one where you're not running, say, your own EC2 servers or your own servers somewhere. You're kind of just uploading your code and you're not managing the scaling of it. But serverless is also a specific tool set for implementing that architecture. And so there's a product and a set of tools, both be using the general term of serverless and the specific tool set. And I'll try to clarify when I'm talking about the tool set. So it's kind of, serverless in Lambda is kind of not a big deal. It's a pretty easy concept. And kind of, it harkens back to the old days of CGI bin, which probably some of you on this call remember, and some of you on the call, it's before your time. But back in the good old days, like this is 20 years ago or 25 years ago nearly, people would have, you'd have your like ISP, where you get your internet from, and they might give you a home page type of thing, and you would upload files, your HTML pages, but the web server also had a CGI bin directory, and you could upload files into that directory, and those files would be executed. And so a lot of the early internet was built on CGI bin with Perl scripts or other kind of scripts that were just very simple. And the deployment model was really easy back then. You just kind of wrote some code, like PHP or Perl or whatever, you zip it up and you upload it to your web hosting server, and it just magically runs, and you kind of didn't worry about it. And it worked with different languages. So like, oh my God, there's no servers. That's also serverless. Like, kind of, yeah. A super simple example to make this a little bit more real. This is a Python example of a Lambda that does basically nothing. But you've got your Lambda definition. It's basically just a function. The function's going to get an event that is like an input hash to your function. That's, say, user data. And then it's going to get a context object. And the context object could be useful for learning about what is the kind of computation environment that you're in. Maybe how much memory does it have, or what time did your function start at? So you can see here in this code, we're going to pull out a parameter from that event hash, and then we're going to return a separate hash. This is like a super simple basic Lambda function, but this is kind of the crux of it. Your code could be as complex as you need it inside there. So you can import libraries and you could do all sorts of stuff. So it's also kind of like not a big deal in the respect that your code kind of runs whenever you need it. And there's different ways to invoke your code in a serverless environment. So maybe you could imagine you've got an HTTP API, a REST API. So you could use a tool like AWS API Gateway, and then that serves your request into a Lambda. So when your Lambda code runs, you get an HTTP kind of event request object. Maybe your Lambda runs, or your serverless function runs on a timer. So you have a CloudWatch event. This is kind of like cron. You know, in a cron job on a Unix system, it's going to fire your code, your script, every night or every minute or something. You could do the same thing with your Lambda. Or you can get into some stuff where you're triggering your Lambda when other things happen in the cloud. So I'm going to show an example later in this talk where an S3 upload is triggering a Lambda to run. And then, of course, you could always invoke your Lambda yourself. So you could write a Lambda, and then your main monolith could say, hey, go invoke that Lambda as just an API call to say, hey, here's the input hash, go invoke it. So there's a lot of different ways this stuff can run. And so in some ways, it's not a big deal, but in some ways, it's kind of a big deal. With serverless and with Lambda, you can start to move your team kind of up the stack. And so that you're deploying more the functions and the code of your application instead of, you know, really worrying about how certain components are scaling. And so you can also easily deploy code in different languages. So if your monolith is all in one language, and I'm going to talk an example of this, maybe it's advantageous to be able to quickly deploy code in another language, and you don't want to have to do all the infrastructure to set it up on your own servers. So the way I kind of view this is a really useful tool in my toolbox for some problems. We haven't re-architected our application entirely around Lambda. I'm not going to be advocating that in this talk, but maybe that's actually appropriate in some cases. But the other thing that's really kind of a big deal is that you only pay for what you use. And there's real trade-offs here. So you know, if you were to just rewrite your app that is already, you've invested years scaling it on EC2, and you just want to rewrite it on Lambda, it's probably going to be more expensive to run it on Lambda because it's a different environment and it's different trade-offs. But there's a lot of really interesting things about per function billing. And it's also kind of a big deal that a lot of the stuff that you're probably familiar with today from your monolith, scaling your monolith, tuning your monolith, monitoring it, making sure it's working, logging, all of those things, you need to figure out how to do those in a serverless environment. And they're going to be similar but different. So I think that's kind of a big deal. I want to drill into the finance aspect of this because I think this is like, maybe developers initially might not realize this, but this is, I think, a really significant deal. So in today's server world, you know, I pay for my EC2 servers. All of our code runs there. I don't really have any kind of granularity in terms of the pricing or anything. My compute is kind of all lumped together. In the serverless world, I get per function billing. So each one of my individual Lambda functions, I know how many invocations it had. I know how many, the resource side, and exactly how much it cost me. In fact, it's a line item in my AWS bill. And so I think this is going to lead us towards this weird world where we have kind of revenue-based development, where you actually ask yourself questions with data like, is it cost effective for me to refactor this? I could make it twice as fast, but if it's only going to save me $7 a month, probably you don't care about that, right? Unless the performance is a big concern or something. So I think this like financial, I don't know what the name is, FinOps, I don't know, someone will invent a name in the upcoming years. Okay, so that's kind of a little bit about the technology in general. I'm going to show 4 examples that AWS Lambda was really helpful for our monolith architecture. So first off, we're going to talk about kind of just offloading work from a core application, right? So you've got your monolith, maybe just going to carve off some work. So we've done that. We've done a little bit of like edge routing. Lambda's running right at the edge and affecting the routing. We've got some event-driven triggers that I mentioned, and then we are going to talk about how to do kind of an architecture extension on our product where we use Lambda as the extension points. All right, so first off, offloading work. So here's the context, right? Like any app, you know, our app's like 8 to 10 years old. And, you know, in the early years of a business, you know, you're not even sure that the business is going to make it. And you're just like, there's a lot of uncertainty, right? And so you kind of do what's quick. And you got to evolve your architecture. And so naturally, some of those things that you build initially are going to be slow and going to become performance if you're so lucky to be successful to have to scale. And usually, you know, when you have a slow API, you look at like caching or indexing or like doing something like that. But there were two API endpoints that were particularly challenging for us to scale: PDF generation and image resize. And both of those relied on us using kind of third-party open source libraries that we would call into. We couldn't really optimize those beyond that level, or we didn't wish to invest in that. And so one of the kind of risks was that these APIs were quite slow, and if someone was to bomb us with a whole bunch of requests, it could actually saturate all the capacity that we have. So this is kind of a risk to us. So in the old style, you know, in a server environment, it was just like any other API request to our backend. Our backend got the request, figured out what needed to be done, shelled out to some script to create a PDF file, say. In the new style, we basically rewrote that one API endpoint to generate a PDF, and we built just that API endpoint in a separate code base written in Golang. We wanted to use Golang for various reasons, but it could have been done in anything. It has a very separate, very small code base. It's quite small, easy to grok. It's got unit tests around it. We upload it to Lambda, and now basically it scales to infinity. It's not really infinity, but for our purposes, it scales way beyond the needs that we would have, and I don't need to do anything. It's just, if I want 1,000 concurrent PDFs being generated, no problem. Lambda is going to do that. I'll have to pay for it, but that's okay. Because most of the performance of this was the invoking of the WK HTML to PDF utility, the performance was basically the same. So the overhead that we have to pay for Lambda spinning up was negligible compared to the cost of these requests, maybe 2 to 3 seconds per request. So the benefits of like building this is basically like we instantly stop worrying about scaling and concurrency of this part of our application. Our main API gets lighter because it's doing less work. It doesn't have all these PDF and image generation requests. So now our kind of existing infrastructure just has fewer requests, more capacity. And then the costs are super directly quantifiable, as I said in the past. So like I went for this presentation, I went back and looked at the math on this, and like we built out this system, and like my alternative was like spinning up more EC2 servers for our core application, core APIs. And instead, this cost me a whopping $25 a month for 166,000 executions of PDF generation, right? So like when I look at that cost relative to the rest of my infrastructure, it's pretty marginal. And I just like contrast that with like all the effort we would have to spend scaling up our main app if we chose to not architect this piece out. So basically, it was small and easy to write. It took maybe a couple days for a developer to port, including all the testing and everything like that. And it's kind of frankly been set it and forget it, you know? So that's example number one. Example number two. ReCollect makes an educational sorting game. So you can go check it out after the talk, vancouver.recycle.game. Maybe actually your city that you live in. If you're in North America, there's a good chance you have this game as part of ReCollect. And basically, we wanted really nice, clean URLs. We wanted I really like clean URLs. So we wanted to have really clean URLs, but then the file structure, you know, this is all served out of an S3 bucket, and the file structure wasn't quite, you know, matching that. And there's different ways you can approach this. So I'm not claiming like this is the only way you can solve this. You can use HA proxy and rewrite things, or Nginx and all sorts of stuff. But what we discovered, we kind of had a little bit of experience with AWS Lambda, and we noticed that the AWS CloudFront, which is a CDN, a caching network, it has this feature called Lambda at the edge. And it lets you write a little Lambda, and then that Lambda will run at all these edge nodes on their CDN. So it'll process the request and then feed it back into the S3 bucket. And so basically, this is the Lambda handler. Just to make it one slide, I've deleted, like, say, error handling and comments just to fit it in there. And my apologies for the giant regex that does not have a comment in this version. But basically, we're looking at, like you can see, that top event object coming in. The event is going to be an HTTP request. We're going to pull out the domain from the host header. We're going to match it to find the subdomain. And then basically that kind of bolded line in near the bottom is setting the new URI that we're going to redirect to. So this is doing this really lightweight transform of these API requests as they come in. This takes a couple of milliseconds to run, map the request to a new URL, and that's the URL we're going to serve from our S3 bucket. So this is kind of like I'm adding a little bit of infrastructure, but on the other hand, I think it's less overall infrastructure to worry about. It's a really simple component. It works like the analogy that I have in my mind is like this is water flowing downhill on the easiest path, right? This is a very simple way for us to get what we wanted to happen. The Lambda took like maybe an hour to write, again, including tests, maybe 2 hours including tests. Very easy to build that, very simple, small function, easy for someone to go grok. And because our team was familiar with these technologies, we could basically quickly build a low maintenance solution. And again, the cost is super negligible. This Lambda doesn't require any memory, and it's just super fast execution time, right? So we're just paying per 100 millisecond chunk. So anyways, this is a great success. I've literally not looked at this code since we launched it. All right, example number 3, event-driven triggers. So in the past, as a context to this problem, our system would get data updates from our customers, and our customers would upload them to an S3 bucket. They might use SFTP or something like this, but they end up in an S3 bucket. Sometime later in the middle of the night, our system would come along, cron job would fire, and it would go check the file in that bucket and say, has it changed? And if it's changed, let's run an update. This is pretty standard. But we're like, hey, we could really easily make this like a real-time system. So AWS Lambdas have a trigger based on S3. So in the old style, our core monolith app had code plus a cron job, and the cron job would run. It would go check in S3. It would either need to maintain state about that file in S3, like the checksum that it had last time, or it would just blindly run each time, right? These are not super ideal. In the new style, we create a trigger based on an action or an event called S3 object created. And this trigger fires for brand new objects created, or if you upload a new object to the same path, like kind of updating an object. And basically, when that happens, the system, AWS, just triggers our Lambda. And then our Lambda, we wrote it using the serverless framework. We've really started loving the serverless framework for the serverless work that we're doing. So if you're looking into it, I'd check that out. I've got an example coming up. And basically, it triggers an update via our API when it changed. So this is what you call a serverless.yaml file. And the serverless framework, again, this is not like general technology serverless, but this is the serverless framework. It works with like Azure and Google Functions and AWS Lambda, so you can use it with your thing. But basically, you define, what the resources. If you've used like Terraform or Puppet or Chef or something, this is kind of similar to that. So basically, I'm giving it a name, S3 connector hook. I'm saying, hey, this stuff lives on AWS, certain runtime. I don't think this should take longer than 3 seconds. And then I define the function. In this case, I'm defining a single function called conhook. I'm saying, hey, here's the JavaScript code. There's a run function that'll happen. And then the events that are going to trigger that function are S3. And so I give it a bucket name. I give it the event that I wanted. And at the bottom there, I can define some rules, like it has to be in this directory and it has to have this suffix. And so I can filter out the kind of files that I'm interested in. I would then use the serverless tools to run a command line. It's going to go upload my function. It's going to create the permissions. It's going to create everything. Build and compile the Lambda code, upload it, set up the trigger. It's going to do all of that. It's really nice. We really like this serverless framework. So the Node.js, this code is a little bit longer than the other example, and so I haven't included it. But in a nutshell, what it's doing is it's receiving an event in that function of the file that changed. In the past example, it was an HTTP request as the event, but in this one, it's an event from an S3 change request. That Lambda, all it's doing is just calling into our main app using our existing REST API, and that REST API already existed for other reasons, so this was a really low build. It's just calling into our API. And this thing has a separate small code base, and it's very easy to test and debug. It's very easy to go in and grok it. It's just a simple script. So this has been really great. Since we did this, our updates to just flow into, as soon as our customer uploads it, it flows into our system now. And this was like an afternoon of building this integration. Okay, example number 4, extensible integrations. This is the most complex example, so let's all just take a breath together. Okay, so in ReCollect, our system forwards requests onto lots of other third-party systems. So, the context here is like, we sell our system to lots of different municipal governments. Each of those governments uses different back-end systems for their ticketing. Some might use like Open311, which is a little more general. Some of them might use Motorola systems. Some of them might use, all sorts of different systems. Probably you've not heard of many of them unless you're in the municipal space. Each one of those systems is different. They have custom code and custom ways. Some of them will be a REST API, nice and simple. Some of them is like kind of a ghetto REST API that you need to do multiple calls. Some of them have to do OAuth calls. Some of them might be SOAP or something that's like kind of gross. So every new integration, I was asking myself, we're adding more new code to our big backend monolith. And every time we do this integration, which is good for our business, it just increases the kind of code bloat of our core application. We might need to pull in SOAP libraries or this. And so I, as an architect and CTO in my company, am thinking, okay, I know we're going to want to do a lot more of these in the years ahead. How can we lower the cost to build these? And how can we reduce how much new code? So thinking about this problem of how we do this integration, the other thing I realized is some of these integrations would be a lot easier if I could write them in different languages. So if I had to build this integration on our backend monolith, I'm going to need to write it in that language. And if I were to write it and our backend is not in Node.js, but I noticed one of these systems, Freshdesk, for example, they have a Node.js library that makes it super easy to push content into their system. And so if I could write my integration in Node.js, well, then that integration becomes way simpler for me to write. I don't need to do raw REST API calls, HTTP calls, for authentication. I could just use their library. And when I look at the types of integrations we're doing, and this is in our core monolith code of the existing ones we've done, I'm like, hey, these only differ in two ways. One is how do we map the data into that other system? And the second one is, how do we deliver the data that's in the data structure into their system? And that may fail for various network reasons. Their system may be down for maintenance or network glitch or something. And so we might want to retry that. And I also kind of didn't like that if I make a small tweak to one of these integrations, it requires a full deploy of our whole monolith application. And then thinking ahead, I'm going to add many more integrations in the future. So do I want to keep going down our current path of just adding more and more to that monolith? Or do we want to look at something else? So we ended up using something called AWS step functions. At this point, I want to acknowledge I'm pitching a lot of AWS products. I have no affiliation with AWS other than I pay them money each month for using their products. So, all of this stuff exists, or a lot of this stuff exists on other platforms too. Maybe not step functions. Step functions is basically a state machine as a service. So in the middle panel there, that's JSON code. What that's doing is it's defining a state machine structure. So you can see on line 3 there, it says start at prepare request. That's kind of the initial state of the state machine. And then it has a states hash on line 4, and we're defining the different states that are in our state machine, the data that they get, the retries and error handling that we might want to do, where it goes next. And so on the right-hand side, you see a visualization of that state machine, right? So when everything goes smoothly, we're going to get some data that we forward. We're going to prepare it. That means mapping it from our data structure to the integration. It's going to be unique to that integration. That's going to finish up. That's going to call send a request. Send request is then going to be in a state where it's going to keep in that state until it delivers the message. So there could be network errors. It'll just do exponential backoff retries. And then assuming that the send request worked, we want to go and update our system. So that forwarded state basically calls back into our API of our monolith and says, hey, this thing finished. Okay. What's interesting is that the forwarded and then the fatal error, which is just error handling, alerting our team and stuff like that, any cleanup or whatever. Those forwarded and fatal error states, they never change. They don't change between different integrations. And so what we ended up doing was the forwarded and fatal error, they each have their own Lambda function. And that Lambda function is shared between all of the state machines that we have. And then for each different integration, we want to integrate with that system or this system or that system, each of them has their own state machine. And in their state machine, the prepare request and send request functions are unique to them. So in this way, we've got kind of this 4-step state machine. 2 of the steps are totally unique to that integration, and 2 of them are shared. Okay. And then each of those lambdas could be implemented in their own language. So if we wanted, we could implement it in .NET if it was like some kind of library that was helpful there, or we often do Node.js. So in the old style, just to kind of revisit, all of our code lived in our core app. It was growing and kind of bloating with other libraries and dependencies we needed. Integrations must be implemented in our core language of our monolith, and it required knowledge of that existing kind of core system. And in the new style, each integration has these very small, simple implementations that are just very focused. That prepare request in all of our integrations is dead simple. It's just a Lambda function that's mapping our hash to their hash. And it can do, we can do like custom stuff. So if that integration, we need to do, something unique, add extra field or check this thing before and do this or that, we can do that. The code is very dead simple. It's very easy to test using these Lambdas, Node.js. It's very easy to use Mocha or other test frameworks and just do your testing on your node. And because the scope of the overall solution is small, the testing ends up quite small. And now that these are small little functions, I could even outsource this. So I could hire a developer that doesn't know anything about our core application. All I say is, hey, I'm going to give you this input hash. Here's an example. And I want you to map it so it looks like this. And then I want you to write a Lambda that's going to send it and deliver it. And so you need to know very little about our core system to be able to do that. So this is now like, if we actually get slammed and have to do a bunch of integrations, and some of these are hard, I could actually scale up our dev team in a way using this technology. And then the step functions are going to handle retries and errors and all of that kind of stuff. So those are 4 examples. Let's just recap for a little bit. I think on the one hand, this technology is not a big deal. It's super easy. You can try it and you can get started with it really easy. It's not like something you need to roll out all across your whole organization. Because it's serverless, you're not installing things on your servers and doing all of that, right? So it's like, write some code, upload it, and invoke it. That's about it. Simple things are very simple. And because you're building smaller programs, just a lot of your life gets simpler. And so I think it's quite easy to get started on this. And like my suggestion would be try, like the first time you start using these technologies, try doing something non-mission critical, right? We did it with some of these examples were things where we could build a parallel system and test it out and make sure it behaves as well as our good system. And then once we got confidence, we could flip it over and kind of keep that as a switch where if it failed, we could point it back as we build confidence, right? Maybe there's a hack day project that you want to try. On the other hand, I think this stuff is quite a big deal. I think it's where the future is headed. And I'm going to have a couple more slides on that. I think it introduces the financial aspect to development in a way that's never been done before. And I think that's going to have a big impact on our practices in the next 15 years. And I think it's a powerful tool in an architect or a CTO toolbox, where you want to outsource work or you have your core monolith and it's like, we could do it this way. It provides another way to kind of easily scale parts of your app. And I view this as a new set of emergent practices. So I think like, this serverless stuff is really quite new. People are definitely getting a handle on it. You see tooling being built around it. But there's going to be more and more practices that embrace that financial aspect and just this is going to become the best practice, I think. So there's a couple things I think that you should be thinking about for your teams. One is like, I think you should be experimenting with this tech. Maybe I've not convinced you should go all in on this, but I think it's worthwhile to find some small projects where some people on your team or you and your team can learn some of these skills so that you're familiar with it and you understand some of the trade-offs and know where it can be applied. I think each of our systems are going to have places where this would be a fit or maybe wouldn't be a fit. And we all have our own context. So I'm not saying like you definitely should use this, but you should understand the implications of this and where it could be useful. And I think also that experimentation and trying it out, I would encourage you to be doing that before you had to use this on a real important main production project, because you're going to need to learn about this like emergent practices of serverless debugging, serverless logging, serverless monitoring. Those are going to be simple to the things that you're already doing today, but they're going to be different and different enough where, when you learn new things, it feels awkward and clumsy at first. And I think this is going to be the same. You're going to be like, hey, I could just do this in 5 minutes using my monolith app. Why am I doing this? And I think what you're trying to do is trying to learn new skills and understand where this could be more useful in the future. So how do you debug in a serverless world, right? Through your logs. Well, where are your logs going? How different is that? What infrastructure do you need to set up for your logging so that it works? Like in our situation, we use a company called LogDNA for centralized logging. And we have our Lambdas feeding into log DNA. But that's great, and it works good. But that's some work that we need to set up, and we need to build that infrastructure for our team. So hopefully these are all questions and skills that you have today with your monolith that like you're answering and you're dealing with. And so you can kind of figure out what are the answers for serverless stuff. And I think the best practices are still emergent. On the maintenance side, I don't think it's zero maintenance, but it's close. In fact, it's so close that you'll probably forget how some of these Lambdas work. You're going to be building this Lambda, you're going to set it and forget it, it's going to do its little edge CDN routing, and then 2 years later, AWS is going to send you an email and says, hey, by the way, Node.js 8 is going away. You need to upgrade to Node.js 10, or whatever it is. And you're going to need to go and find your code. So you're going to need to figure out which Git repo you checked it into. You're going to need to port it over to run on 10. You're going to need to retest it to make sure you haven't broken it, maybe fix up a couple things. So understand that this is coming and that will be your reality. So don't just build a system and then just move on once it starts working. It's really important. And again, this is not like a serverless unique practice. This is what you should be doing for all your systems. But like document your systems. Even if this is a small little Node.js function, like every system we build, every like subsystem has a wiki page, and it describes a picture of the architecture, a diagram of the problem it's trying to solve, and the context it was developed in, how to make a change, how to test the change, like how to do development, how to debug in production, how to deploy, right? You're going to forget these things. And especially, if you have a team, maybe someone's going to set this up and then leave, and you got new people to come in. So documentation is incredibly important for this stuff. And then I think there's also big finance implications. So when you get into the serverless world and you have more and more of your infrastructure on this, should I refactor this code if it's only going to save us $8.42 a month, but it's going to take me 5 hours or a developer 5 hours to refactor it? Probably not. Like, if so, then you've got some budgeting problems, right? On the other hand, this Lambda, maybe it was started at $200 and now it's up to $600 a month. And your CFO or your controller is like, hey, Luke, I noticed your AWS bill is pretty high. And you look at your line items, you're like, wow, that function's being called a lot. That feels outsized to the value that I'm getting from it. Okay, now we can allocate some amount of developer time to optimize that, right? So I think in the past, we never had this kind of granularity. And I think the finance side is really interesting. Okay, another deep breath. Terry, do you think I've convinced them about why this stuff is the future? Or should we get into maps?
I mean, I think that you probably got enough time left to spend some time in the maps. And I always think this stuff is interesting. So I think go for it.
Let's do it. Okay, I'm going to try to cover 30 years of computing history in the next 9 to 10 minutes. So let's do this. Okay, so this is a Wardley map. I would love to know how many people on this call know what a Wardley map is, but a Wardley map is basically a communication device, okay? So the purpose of this is that I could draw a map, and then Terry and I could have a conversation about this, and Terry could challenge my assumptions, okay? So on the vertical axis, at the very top, you have users at the very top, and then you have their user needs. And so you go down the stack, and you can see the dependencies, right? So the public wants to come in. They want to buy a cup of tea. To serve them a cup of tea, you need a cup, and probably don't care where that cup's from. You need tea. Most likely, you don't care where that tea is from. Maybe you want it, eco-friendly or something. You need some staff. You need some hot water. The hot water has to, the water's got to come from somewhere. Usually, you're not really specific about the water. It's just out of the tap. And then you usually don't care when you go for a cup of tea how the power was generated. And most likely, you don't care about the kettle. So I'm pitching this idea to Terry, and I'm like, hey, Terry, we're going to start our tea shop, and it's going to be great. And I'm like really amped about these custom kettles. I found this guy makes amazing custom kettles. And Terry can be like, Luke, I think it's a bad idea for us to have custom branded kettles. We can just go to Walmart and we can buy one for $8.99. It's going to last us so long. If it breaks, we'll just go buy another one. Like, what is the? So this is just a communication device, okay? On the the left-right axis, you have evolution. Okay, so in the first kind of segment there, you have like Genesis, like this is like a hack day project. This is an idea that we're just like stitching the code together. It's like very rough. In the next category, you start to get into custom built solutions. So in this case, like this is a handmade kettle from the guy up the street that makes kettles. These are amazing kettles, are copper plated and everything. And then in the middle, you get into products. This is like, it's not a custom build. This is like a SaaS product that you can go and rent, or like, fairly replaceable. And then in the far right, you have commodity and utility. So there's very little that discerns one item from another. It's a commodity. You don't expect it to change. It's like the power is going to be 60 hertz no matter where you are in North America, say. Okay, so that's just like what a map is. We're not talking about T, though. We're talking about computing. So let's look at a computing map. This is like pre-clouds. This is like 20 years ago, okay? So remember, we used to all run our own data servers, right? So some people here probably never have had their career in this. And so, you got the customer at the top, and they've got some online photo storage and online image manipulation. We've all custom built that. It's our own custom code. That's all built on our website. We're renting some website, like, in some platform, computing platform. We've got our servers that are in the data center downtown. So we're kind of managing our own data center. And the power is just a utility. We don't care about power, right? And so in this world, like way back then, you tended to like run all your own servers in a data center. And so when you wanted to scale up, you tended to buy really beefy servers. What's the biggest server we can afford? Let's put a couple of them in there and run, okay? I'm keeping this quick. However, then we started having people that were running hundreds or thousands or tens of thousands of machines. And that's where you started getting scale out, right? So instead of buying really beefy servers, we just need so many. We're just going to start to scale it across so many servers. And so when you have to manage hundreds or thousands or tens of thousands of servers, you have to develop new tools and practices. And so one of the practices that grew out of this like 10, 15 years ago is called DevOps. And at first, DevOps was this like wild crew of people, and they were saying, no, you shouldn't name your servers. That's like treating them as pets. You should treat them like cattle that you're going to cull at the end of the season. And that was radical. And they said, no, you shouldn't have a separate IT team that deploys it. You should a separate ops team. The developers should manage all of this. And you should have the infrastructure should all live as code in like config files. And there was a time where all of these ideas seemed crazy. And hopefully we're in a world now in 2020 where like none of what I actually just said that seems crazy actually seems crazy. That all just seems like best practices, right? So you see here in this chart, here we're not graphing like those clear circles are activity along the bottom, but then we're also mapping practices. So an emerging practice moving towards a good practice, towards a best practice, okay? So the scale out practice depended on commodity utilities. It depended on being able to spin up 1,000 EC2 servers at the click of a button, okay? So you've got a lot of servers. You've now got things like Lambda and Google Functions. And if you're into Heroku, this is very much the same as that, right? If people have been on Heroku, they haven't had to deal with a lot of this stuff. They're kind of like on this platform serverless model. And what happens is whenever you have something that kind of evolves to the right into that utility, once it becomes a utility, you tend to have an explosion of innovation in that Genesis and custom built phase, right? People are building brand new things on it. And one of the things that's happening is this emerging practice of serverless software development, FinDev or DevOps 2.0 or some daft name, that's being invented. And that's the practices that I've talked about in this slide. And we're still figuring out like what are the emergent practices becoming best, or like good becoming best, right? And so I think it's really worthwhile that if this is the trend, I think this is the trend that we're going to go away from managing our own servers and we're going to care less about Kubernetes and everything below that red line. There's going to be people in this world that do need to care about it. They're going to work for AWS Cloud, Azure Cloud, and Google Cloud. And as application developers, we're going to be just caring about the stuff up above it. So I think it's a good idea not to invest wholeheartedly in this, but to start building capacity in your teams and understanding this technology so that as you have more and more opportunity and as this tools mature and everything, you can start using it. I'm going to end on a bonus slide. This is a slide from 2030. This is from the future. And this is how it's going to look. We've got our application. We've got our development tools and our best practice that mix software development and financial prudence. And then we've got our code environment where stuff actually runs, and it's just a commodity. We kind of just don't care, so we just like have our zip file and we upload it. And then we're gonna, your kids are gonna talk to grandma and grandpa about them racking 1U servers in a data center someday, and we're not gonna really talk about those in our companies. And so just, what tools are we gonna be using in 2030? What skills should your team start developing in advance of that? And what architectural choices are you making now that are gonna have lasting implications? So those are the big questions I'm asking myself. I encourage you to ask yourself. So I think with that, I'm gonna end. And I'm happy to take any questions. If you see the slides, there's this one last slide. It's got some good stuff. There's the first link is the Wikipedia to Wardley Maps, and the second one is a Medium book on Wardley Maps if you want to learn more. It's a great communication device. Okay, there we go, Terry.
All righty, I am just making my way through the questions here. So I'm going to start off with this one. What really is different between platform as a service and serverless? Look at Google, App Engine, Flexible, and Firestore.
Yeah, I don't think there's much difference. I think the name, right? These are all just kind of the same ideas pointing at the same concept. Platform as service like Heroku or app, whatever the one you mentioned is. Yeah. You're basically uploading your code, you're giving it some parameters for how to run it, and then it's taking care of the execution environment and scaling and stuff like that. So I think these platform as a service, serverless, is kind of the same name, same thing.
Okay, next question. How can serverless replace DevOps, which is mainly about build and test? Do you mean there is no build with serverless since it is atomized?
I don't mean that there's no build. For instance, the Golang thing that I built, Golang ships a binary. So when we want to ship a new Golang, we run make or whatever the command is, go build or whatever, and it will build that binary asset, create that as our zip file, and then deploy it. So we still have a build phase. I don't really know what I mean when I say there's going to be no DevOps. This is kind of more of like, hey, the practices are all going to be changing. In the DevOps world, we really care about, like, say, spinning up our EC2 instances and the OS that they're on and installing certain packages. I think those are the things that are going to go away. And instead, we're going to be focusing more on just that zip file, just our application. So there's going to be a build, npm install all our dependencies for a node application or whatever. Like Golang's going to need all your Go dependencies and pull all those in and build it. We're just going to focus less on the stuff, like to flip back a slide. We're going to focus less on the stuff below this red line, right? So like containers are cool and all, and Kubernetes is cool and all, but ultimately that's going to be kind of an implementation detail. And we're more going to care about, here's our core application, the dependencies we need, but we don't care really what operating system it's on and stuff like that. So it's kind of like a little bit of a radical statement that there's going to be no DevOps, but I'm really trying to indicate here, like, the DevOps came out of this world of scaling out to hundreds of servers, thousands of servers. And now we've got a new set of emerging practices that are going to steal good ideas from DevOps, steal good ideas from the previous legacy, but kind of invent their own thing.
Okay, next question. During development of a new Lambda function, are you constantly deploying it to AWS, or do you have a way to run it locally in a way that simulates the deployed environment?
Yeah, super good question. Definitely the latter. What we do so lately, all the new build that we've doing on Lambda is using the serverless framework. So with that framework, it's really nice. You can say, from command line, you got your project directory, you say serverless, invoke your function name, and you can optionally pass in data, right? Or a JSON file maybe you have as the data file. So you can say serverless, invoke local, and then your function name. And when you say local, invoke local, what it's going to do is it's going to spin up an environment that looks identical to Lambda. It's going to call your Lambda function in a way that looks identical to Lambda, and your code's going to run. So I would be doing that really quick. And I would also, my Node.js code, say, or my Golang code, will also have extensive unit tests. So those unit tests, I don't need the Lambda environment for. I can just run my unit test, test out my code, test out the code. And then when I'm ready to test it kind of full stack, I simply invoke local with the serverless framework and pass in whatever data I want, and I can verify it. I tend to do that most of the time, the local invoke, And then maybe once I get to like a milestone, I'll push it up to Lambda, and then I'll invoke it there and just make sure everything works. When you invoke it there, you're testing slightly different things. You're testing like, did my dependencies all upload correctly, and do I have enough memory, and all of this kind of stuff. So both testings are useful, but I tend to do the development locally. You can use practices like test-driven development, because you could build out modules and test those, and then your Lambda is really just calling into a handler. So I hope that answers the question.
There's a kind of a specific one around some AWS technologies, but I think it has some general applicability. If you have an API server that uses Elasticsearch, i.e. something that maintains state in memory, can you migrate it to Lambda functions, or would that be inappropriate?
So the Lambda function, you should consider it as totally on its own, like it doesn't have state, kind of like back like a CGI bin script wouldn't have state. So what you tend to do if you need state is to use like a DynamoDB or some database or something like this that you can quickly use. I'm not sure I have advice specifically for Elasticsearch. I've not used that. But it's easy to imagine like a lightweight Lambda sitting in front of or behind your REST API, but before your Elasticsearch that could modify that really, in a light way and then pass it on to Elasticsearch or something. Definitely could have your Lambda call into Elasticsearch and return. We do something similar with Solar, not on the Lambda side, but with our API. You call into our API and our API calls into Solar. I think you could do the same thing in serverless.
Next question. Do you see serverless functionality using less application state backed by persistent storage? In other words, does serverless logic correlate with relatively stateless functionality logic?
In the examples I've given, yes, right? Because what I've tried to do is to say, hey, what are my pain points with my current architecture? And then I've only cherry picked the examples that are suitable for Lambda to show you, right? So in most of these examples, there's very little state. But yeah, so I would just say this is a talk mostly focused on people with monoliths that are trying to experiment with this, right? I think this is just to come back to emerging practices, is if there are people today that are building their entire software solution all on serverless, but they're relying on DynamoDB or Postgres or something to keep that state. And I think a lot of that is still emergent. That's why I'll leave it there. I don't know.
Okay, there's a couple of questions that relate to security. I'll read one out, and then there's another one that I'll tack on the end as well. Do you have specific security mechanism for checking any possible vulnerabilities that exist in Lambda and might cause data leakage to other services in the cloud? Do you work with security tools mechanisms for validating inputs to Lambda? And possibly a somewhat related question is, can you define a Lambda for local use so that it's not public?
Yeah, totally. Okay, so let me tackle the last part of that first. So you upload your Lambda to your AWS account. Nobody can see it, nobody can call it unless you expose it to the world, right? So you could create a Lambda that nobody can see or call in or knows it exists, but you could use the API, the AWS command line, for your specific account to invoke a Lambda. Okay, so that's one way. It's only when you hook it up to an API that it would be available via the API. I think all of your questions are not unique to serverless. You have to answer those questions about managing the quality of the data coming in, the security of the data, and scrubbing it and everything. You have to manage that in serverless and serverful architectures. With AWS Lambda, again, I'm not trying to sell it, but I know they have security groups where your Lambda could run inside a security group where maybe it has limited internet access, or it has access I've experimented with non-public Lambdas that have direct access to our Postgres database, and I could give them IAM permissions for certain tables or for read-only access or something like this. So far in how we've rolled out Lambda, I have not done any of that. So I've just kept very simple Lambdas that call into our REST API. They kind of go back out to the internet and come back in via our REST API. And there's certain architectural reasons that we like doing that, just to keep the monolith code all in one place so we don't have other people poking into our database. I think you need to answer those questions no matter what you're doing. I think that's kind of like best practices around your development, is like being very careful about user input and these kind of things. I personally don't freak out too much about the Lambda stuff, like leaking out to other cloud functions or anything. I mean, the core of what they're trying to offer us here is isolation from all of that. I can imagine that there are super security sensitive applications where you maybe need to wait 5 years before you use this, before the tools evolve and emerge stronger. But I think for most cases, the security is already very good.
This one, another one, I think maybe a little bit related to the kind of DevOps questions, deployment. So with respect to deploying to Lambda, are you versioning your binaries? How do you version your binaries? How do you know what's deployed?
Yeah, great question. So every time you deploy a Lambda up, it creates a new version of your Lambda. And so you can then there's two techniques you can use. You can pin to a specific version. So you, in your HTTP API gateway, you could say your API gateway could have, several different stages. It could have a test stage, a staging stage, and a production stage. Each one of those could be hooked up to separate versions of your Lambda. So you can also tag your Lambda with the API from AWS. So you could say, I'm going to upload it and I'm going to tag it test. And then it's now available from my test API. Maybe you run a test suite. And once that passes, now I tag that version staging, and then it goes to our staging server. And so you can make it so to deploy, all you're really doing is bumping a tag so that the prod tag, instead of pointing at version 47, it now points at version 48, and now it's live. So in one of the examples I mentioned in the talk was our images API, and we do that. We have a continuous integration pipeline where we build out our Golang application, runs tons of unit tests against it, and then it builds and it auto deploys to the test stage. It automatically runs full API tests against that test stage, and then automatically deploys it to staging. And then a developer runs a command to update the prod tag when they're ready to deploy it to prod. So yeah, definitely lots of versioning, lots of stuff you can do there.
Here's one relating to debugging. So if you have an application that contains potentially a very large set of Lambda functions interrelated, how hard is it to troubleshoot where something's gone wrong when something unexpected happens?
This is good. I mean, this is, I don't know that I have a super great answer for this, other than to kind of come back to my slide, which is that there's emerging practices around all this stuff, right? Which is kind of like maybe a bummer answer for you to hear. It's kind of like, hey, you need to maybe figure this out, or like Google what's the best practice. I know the AWS tools have something called X-ray, where you can give an identifier that's tracked through many requests. With Lambda, by default, all of the logs, all the output that the Lambda generates goes into CloudWatch logs. So, you can record IDs that go through there, and then you can grep them or move all those logs into your, log DNA or your other solution. Yeah, I think that, it's just like with serverless. If you had a server full application and you've got a whole lot of components dealing with it, even if you're managing it, you have that same kind of logging challenge. So I don't think like serverless totally solves it, but I don't know that it makes it a lot harder. Each of those functions are going to log independently. You can merge them together and grep them all together with a common identifier. Probably be my suggestion. I'm not an expert in X-ray, AWS X-ray, which is, I think, the solution that you're looking for, but you could maybe Google that and find out more.
Another, I think, question just around product choices and maybe the differences between some of the kinds of services that people are offering. So I don't know whether you'll have the background to answer this, but for a typical web service, would you run it on Lambda or Elastic Beanstalk? And what would cause the decision points there?
I'm always a believer that any choices you make are super dependent on your context, right? So, what I would first look at is like, what is your existing team doing? What are your existing skill sets? What are the skill sets of the people on your team? And like, where are you trying to build skills, right? So to me, that's the crux of it. For my team, if I'm rolling out a brand new service, I'm probably going to take a look. Hey, would this be appropriate for serverless? Could we build it in a serverless way? Because the benefit of doing that is you get all this per function billing and lots of stuff, and you just don't need to worry about scaling. And I tell you, once you get a taste of that, of just building something and then watching it just go nuts and be used a lot, that's really nice. And then once you don't have to be scaling your own EC2 servers and stuff like that, that's quite nice. I think maybe cost is another factor to come back to it. So if you have a workload that is making very intensive use of your environment and you really know how much you're going to be using and it's a steady load, maybe you could use Elastic Beanstalk to have EC2 servers and images, and you spin them up and you run them, and it can auto scale throughout the day, and that can be a cost-effective solution. So that can be totally good. It's more infrastructure for your team to manage. So if you're low on ops people and you're trying to, in my team, I like keeping our team smaller, and we try to have developers that are focused more on the application and less on the ops side. So I think it's quite context dependent, but you could really look and you could say, how much would this cost me on Lambda? Probably it's going to be more, frankly, than exact same thing on EC2 servers you manage, because that's going to be more labor for you. Yeah, so that's the lens I would approach it. I think they're both reasonable solutions.
Okay, we've reached the top of the hour, so I am going to do one last question here, and then we'll wrap things up. So let's say we have two Lambdas for two APIs. Both of them are dependent on a single underlying data source. In a monolith, if you change the DB, you kind of have to change both APIs because the system tells you you've made a mistake. With Lambda, how do you manage those dependencies and know what things you're breaking when you change something within the system like that?
All right, Terry, this is a great thing, because Terry and I in our CTO book group are doing I don't know if you can see my screen, but we're doing a book club on this book called Building Evolutionary Architectures, which I'll plug. It's an O'Reilly book. You, my friend, are asking basically about the nature of microservices architecture. And what often happens, and you can read more about that in the book, is that when you start building in a microservice, that microservice tends to have its own database. Because exactly of what you mentioned, it's hard to start tracking dependencies when you have all these different services all using the same thing. So in my team, in our context, we have a small team. If we said, hey, we're going to build some Lambdas and these different things, and our monolith are all depending on the same Postgres database, you're exactly right. I would need to very carefully orchestrate the deployment of the schema change and the deployment of my code. Maybe I make my code backwards compatible, forwards compatible first, then I do the schema change. Then I can go update my code to take advantage of the schema change and get rid of the old code, kind of a three-stage migration. But if you start using more and more microservices, and if they all start using different databases, you totally can get into that mess. This book, just to plug it again, Building Evolutionary Architectures, definitely talks about that. How do you evolve your architecture? How do you evolve your data store? And how is the way you've set up your code impacting that? So I'll leave it there.
Excellent. Thank you very much, Luke. So as I say, going to wrap it up right now. Luke, thank you once again. That was a super interesting presentation. I enjoyed that very much. Even though I had read the slides ahead of time, I still got a lot out of actually having you go through that. I'd also like to thank all of the people who have joined us live for today and for taking the time to attend and participate. As I mentioned at the top, this talk was recorded and it will be available online in a few days at learning.acm.org. You can also find announcements on more upcoming tech talks and other ACM activities at that same website, learning.acm.org, or the primary ACM website, acm.org. As I mentioned, you will have a survey coming in front of you, and we'd really like to ask you to take the time to fill that out, as that, as I say, helps us understand how to better serve our audience, gives you an opportunity to suggest topics and speakers that you might be interested in hearing from in our Tech Talk series. So on behalf of the ACM, Luke Kloss, and myself, Terry Cota, thanks again for joining us today, and I hope you will be able to join us again in the future. This concludes our talks. Thanks a lot.